Hello! We're going to start delving into dynamic memory today, a topic that's going to be pretty important for the rest of the course, and we're mostly going to be looking at it from the context of classes. So the exercises we're doing today are all going to be class-focused exercises that use dynamic memory in some shape or form. To get started, we're mostly just going to be setting things up. We're not really going to be doing any dynamic memory just yet, but we will get to that point. So without further ado, let's pop open a new file. And here's what we have to do. Create a class called physicsObject with 3 variables for velocity, for the x dimension, y dimension, and z dimension, a double variable mass, make a pass-by value function that given 2 physics objects, adds the variables from one to the other, then returns the toString result of the combined physics object. Do not permanently change the objects. All right. So to get started, we'll definitely need a few libraries to help us out. I think maybe just IOStream should be fine for now, and I'm going to write to use the standard namespace, even though it's not really great coding to do so. Later, we'll need a main function to make sure this works. And we're going to make a class called physicsObject. So I'm also going to save a bit of time just by making all of my variables public, but we'll see later in this course why you might not want to do this. And my variables include double VLX, double velocity Y, double velocity Z, and double mass. It also looks like I have a toString function, so I guess I should make that. I suppose that will return a string. I don't think it needs any parameters because it's just going to take a physics object and give me the string representation of it. So let's write that code now. physicsObjects toString class, string method I should say. So string result is going to start with physicsObject mass equals, and now I'm going to need to start to add to my string to build up the result that I want. Now, all of these are doubles, so I need to convert these to strings. So I have a toString here with a capital S. The toString to convert a double into a string is written like so, toString mass. I'm going to add that to my result. I think I might be able to do this. I'm going to compile just to double check, but if I can't, strings have an append method that I can use instead. Let's first just double check that this compiles though. Plus, physicsObject singular, not physicsObjects. Doesn't return, but it will when I'm done. So it seems like I can do this, which is good. I'm going to be returning my result later. And now I can actually do this for all the rest of my results. So, comma, velocity, I guess we'll say x velocity equals toString VELX. And I'm going to do this for all of my directions. Y velocity, Z velocity. Y velocity, Z velocity. Okay, so now I have a function that adds a whole bunch of text together to give me the representation of a physics object in text. It has a mass and velocities in 3 different dimensions. Now let's make sure that we actually can do this. And I'll make my pass-by value function after I'm sure that what I've done so far isn't broken. So I need physicsObject PO1 and PO2. I guess I don't need PO2 right away, but for now, PO1 dot x equals 10.5, just picking a number out of a hat. So we need x, y, z, and a mass. Just gonna put some fun numbers in here, and then try to output PO1 dot to string, and see what happens. Right, it's not called x, y, and z, it's called VEL, x, y, and z. Okay, and run. physicsObject has a mass, a velocity in each direction, and everything so far seems to be okay. Great, we're on the right track. So now I got the start of my physics object, and I need to make a pass by value function that takes two physics objects, adds the variables from one to the other, and returns the string result of the combined physics object. Now here's the thing I can take advantage of. This is a pass by value function, which means that I'm going to pass a copy of a physics object, not the real thing, which means that I can just take one of them and add to the other one. So here's my function. It is supposed to return a toString result. So it's going to return a string. We'll call this add physics objects, and it's going to take physics object PO1 and physics object PO2. And it's going to return a toString, but first I need to add from one physics object to the other. So PO1.mass plus equals PO2.mass. And we'll do this for all of the variables, VELX, VELY, VELZ, and return PO1.toString. Now to make sure this works, here's what I'm going to do. So here's my first physics object. Let me separate that. I'll make another one. Actually, let's format this nicely. So physics object 1. And then we'll do physics object 2. This is PO2. 2, 2, 2, 2. And we'll just replace the ones here with 2s for the sake of having something different. Then I will do combine physics object, and I'll output add physics objects PO1 and PO2 together. And then finally I will output physics object 1 again. So what my code should do, if I did it all correctly, is I make a physics object, I give it all of its velocities and a mass. I print it out, so I know that it is right. Then I make my second physics object with different numbers. I print it out to make sure it's okay. I add two of them together and print out that result. Because I do it by passing by value, I've only modified a copy of it, which I can print out the text from that. But as soon as my code is gone, that copy disappears. And so my first physics object should return to normal, even though I was modifying the copy of it in this program. So let's see if that's true. So I have my first physics object has a mass of 15, the second one has a mass of 25, combined they have a mass of 40. After I've added them together, because I passed by value, my mass of my first physics object is still 15 like it used to be. I didn't permanently modify it, which means I met the requirements here. And you can see all of the velocities add up properly as well. So hooray, done for the first part. Now let's do the second part. Create a static array. So I guess this means not a dynamic array, that has 5 physics objects, create a pass by reference function that accepts a physics object as a parameter, assigns random values between 1 to 1,000 for each velocity and 1 to 100 for each mass, then call that function for each object in the array. Okay, so let's break this down, I suppose. We'll make a duplicate of this because we like the code that we've done so far. This is exercise 2. And let's break down all the things we have to do. Create a static array of 5 physics objects. So let's begin with that. So all of this code we don't really need. I'll comment it out. And we can access it later if we need to. But we want to make an array of 5 physics objects. Okay, so that means I want a physics object array, PA. And there's going to be 5 of them. Okay, so that's my 5 physics objects. Make a pass by reference function that accepts a physics object as a parameter, assigns random values to everything, then call that function for each in the array. So first we'll make this pass by reference function. It accepts a physics object and assigns stuff to it. So we'll call this void setup physics object, and it takes a physics object PO1 as a parameter, and it accepts it by reference. So we'll use the ampersand to make sure that we're actually modifying this physics object. PO.mass is, and how much did we say that it was going to be? 1 to 100. Let's make sure that we are using randomization properly, so we need to include C time and seed our random initialization. Time null. So let's make sure that we are actually going to have random numbers every time. Now, my mass is going to be a random number modulo 100 plus 1, so that way I get from 1 to 100. My x velocity is a random number modulo 1000 plus 1. And the same thing for y and z. So now I have randomized my values for all of my physics object, and I'm going to do this for every one of my 5. So I is 0, I is less than 5, I plus plus. Set up physics object PAI. So the ith element of my physics object array is a physics object. I just haven't done anything with it yet. And then we will output physics object I and output PAI to string. And see if this works. What did I mess up? Physics object array was not declared in this scope. Right, because my physics object array is an array of physics objects, but I don't call it physics object array. It just is an array that has physics objects. So we'll call it PA. Okay, and run. So I have 5 physics objects. They all have random mass from 1 to 100 and velocities from 1 to 1000. And if I run it a second time, I get different numbers every time I go through, relatively speaking, as long as you take at least a second between each call. But that looks about right to me. Not too long. And now we can move on to the next one. Okay, what's next? Create a function called getMomentum. That given a physics object returns a dynamically allocated array of 3 doubles. Each double is the result of one of the physics object's velocities multiplied by its mass. Okay. So we'll take our exercise, duplicate it again. Exercise 3. Here is our new problem. Function is called getMomentum. Given a physics object, make a dynamically allocated array of 3 doubles. So if I'm going to return a dynamically allocated array, I need to return a pointer to it. And I'm going to need to use the new keyword to create that array. And it's 3 doubles, not 3 physics objects, so that should be pretty easy to do. So if it's an array of 3 doubles, that means the type of my, my getMomentum function is double pointer. It's called getMomentum, and it takes a physics object, PO, as its parameter. And I need to make a new double array. Result is new double 3. So I'm making a dynamic array of 3 doubles. Right now they're all initialized to gibberish, like we don't know what the values are. And I need to make sure each of these 3 doubles corresponds to velocity x times mass, then velocity y times mass, then velocity z times mass. So we can just do that one at a time. So result 0 equals PO.mass times VEL PEO dot VELX. Result 1 and result 2 are respectively y and z, and then we return the result. So if I did this correctly, what I should be able to do is, so here's me setting up my physics objects. Now I should be able to get the momentum of one of them. So let's do, say, let's see, double star result equals get momentum of our physics object array number. Let's just grab the first one, why not? So I got a result, and now let's print them all out. X momentum of object 0 equals result 0. And then we got the y momentum and the z momentum, our results 1 and 2. And let's see what happens. Exercise 3. What did I mess up? It's not called get momentum, it sounds like. Get moment. Did I like misspell something? Oh, capital G. Yeah, it's a capital G. There we go. Gotta be very, very picky about the spelling. Let's go. Okay, so the 0th physics object has a mass of 96 and a velocity of 820, which I believe this looks about right. 78,000 if you multiply that together. Then 96 times 315, again, looks pretty close. 743 times 96, also I think that's just about right. So it sounds good to me. We'll do it again, I guess, just to see. There you go, 99. It's almost 100 times 691. Yep, this is 691 short of 69100. 578 times 99. Yep, that's definitely 578 times 99. And 730 times 99 is this number, because if you add 930 to this, you would get 93,000. So hooray, looks like we did it exactly as we wanted. Not too difficult. The main trick that we had to do with this was just the initialization of this dynamic array, which means that when we go back to our main function after calling this, we now have a result that we can refer to. Even though I don't need to mention inside of line 64 here exactly how big this array is, I know how big it is, which means I can reference all of the different indices. Be careful though, because if I try to access result 3, you have no idea what could be there. Moving right along, ask the user to enter a number, then allocate a dynamic array for that many physics object. Modify the physics object constructor to use your function from exercise 2 to initialize the objects at random values. So there's a couple things we're doing here, and again, we're going to split this up into multiple problems. You shouldn't try to do too much at once. So first things first, ask the user to enter a number, allocate a dynamic array for that many physics objects. So we'll do that first. We'll leave behind our get momentum stuff that we just did. And now, right now, my physics object array is a static array. It's always going to have 5 numbers in it, but I don't really want that. What I'm going to do is I'm going to ask the user for a number. So I'm going to say, how many physics objects do you want? And num of phys objects, and we'll input into that. Okay, so now I know how many number of physics objects I have, and instead of writing my array like this, what I'm going to do is make it a dynamic array. So physics object star PA equals new physics object. Did I spell that right? I hope so. And the amount is number of physics objects amount. And instead of 5, we'll do a number of physics objects. And I think I actually already have this set up to use my function from before because that was very convenient of me, although I should use my constructor to do it. And I think it may be the case that this will do so, but I'm not totally sure. So what I'm going to experiment with a little bit is if I don't set up the physics object, what will happen right now? I think right now this is probably not going to work super well, but let's find out. So first I'll compile exercise 4. All right. Let's say I want 3. Okay, so everything started out as 0. And now what I want to do is I want to use a constructor for my, my physics objects. Right now I don't have one. So let's make a constructor. And my physics object constructor is actually going to need to use the setup physics object method. So setup physics object, and what I'm going to pass it is actually itself. I think this is what I want to do, but let's find out exactly what happens. Is this the right syntax? No, that's not quite what I want. So right now, this passes a physics object by reference. Do I need to do star this? Is that going to work? No, that's not what I'm looking for either. Oh, I think I know what the problem is. The problem is I put set up physics object down here, but it needs to be up above. There we go. Although, now I have, actually, here's what I need to do. I want to, in order to make my setup physics object function work, it needs to know what a physics object is. But if I want to use my constructor to call that function, it also needs to know what that function is. So I'm going to declare it up here and say void set up physics object, and it's going to take a physics object ampersand PO. And now I've declared the function. I've said a physics object, and I guess in order to do this, I need to actually do class physics object, declare this as well. So in order for my code to work, because I kind of have different parts of my code refer to each other, I need to declare everything I'm going to be using. So I'm going to have a class called physics object. I'm going to have a function called setup physics object. And each of these relies on the other one. And this way, when I get down to this line of code, this knows what setup physics object is. It's a function that I'm going to define later down the line. How about now? Are we happy? No, we're still unhappy. Invalid initialization of non-constant reference. So can I pass it a dereference of this? Does that work? Weirdly enough, it does. Okay, so let me show you the kind of sort of strange thing I did to solve this. It's not necessarily intuitive, which is why I think it's a good example. So first of all, it's important that I declare things. If I didn't declare these, what ends up happening, and you can actually see it when I compile, is this. My code gets upset because it sees, hey, setup physics object doesn't exist. What is this? This is no idea. So it's unhappy. Okay, but here's the problem. Your first idea to fix it might be, oh, well, we'll just take setup physics object and put it at the top of the code. But now you have a problem. This function requires this class to exist. But this class hasn't been determined yet. Like, what is physics object? We haven't actually said that. So we seem like we're in a bit of a pickle, but there is a solution, which is to declare the class first. Instead of outlining everything you need to know about a physics object, I'm just going to tell the computer, hey, it's a class. You don't need to know more than that right now. We'll figure that out later. Similarly, setup physics object is a function. It takes one of those physics object classes I just told you about by reference, and it will do some stuff later. But don't worry about it right now. We'll see later what it does. Then I say, okay, here is what a physics object is. It's got the velocities, it's got a mass, it's got a constructor, it's got a toString function. Here's the toString function. There's some code from before. Then I can tell it what my setup physics object is, and now it knows what mass and velocity and physics object in general are. So I can write all this code and it's fine. Now what about what I was doing for this exercise? Well, this exercise said to ask the user for how many physics objects they want. So I said, say 3, for example. And now here is the line where some things are happening kind of secretly. This part here is a pointer to a physics object, but it also refers to an array of physics objects. So in this case, I wanted to have 3 of them. So this is actually a pointer to the first of my array of 3, or however many, physics objects. I use the word new to indicate I want this to be dynamic. I don't know exactly how many physics objects I need until the user tells me. And when we initialize this array of 3, what actually the computer does is it calls the constructor of the physics object every single time it makes a new one. So in this case, it makes 3 of them. I don't need to actually have this code in here, but you'll see that in my output, I still managed to get actual values in here without calling the setup physics object code. I do call it, but I don't call it when I'm in this loop in the main function. I actually call it in my constructor. But now the constructor code here looks a bit strange. What's going on here? So my constructor has to be called physics object because my class is called physics object. I don't need any parameters. And this default constructor is the one that gets called when you create a dynamic array of physics objects. What's it do? It calls my setup physics object function, the one that I already made. But what is this parameter? This, The keyword this is a pointer to the current physics object, the one that is working at the moment, calling this method. But here's my issue. I don't want a pointer to the physics object. I want a physics object. I don't have an asterisk here. I want an actual physics object that I take by reference so that I can modify it. So passing a pointer, not very useful. But we know what to do with pointers, right? We use a dereference operator, the star, to go to what's at the pointer, which is the actual physics object itself, and that is our parameter that we pass over. Since we're passing that parameter over, it's taken as a reference, so now we have a pointer to our physics object, and that can actually modify all the values we need to modify. A bit unusual sometimes, but you'll actually see this kind of code right here, pardon the pun, is actually something that you might find fairly common in C++. So, something you may not have seen before, but it is something that's fairly important for being able to set up dynamic arrays of objects. Okay, was there anything else we had to do? We use our function to initialize random values. We dynamically made the array. We asked the user for a number. Seems all well and good. Let's move on. Number 5. Make a class called physics object collection. Let's space this down. With a pointer variable to an array of physics objects. Its constructor should take a single integer, which is the size of the dynamic array of physics object created when the collection is initialized. Modify the previous exercise to use this collection. Okay, this shouldn't be too bad. So, exercise 5. Okay. So, we're going to make a class called physics object collection. Actually, I'm going to put this comment down below because we're actually going to dig a little bit further down in order to write this. I think we'll do it before we've done our main function, just so that we've already declared our physics objects and so on. So my class is called physics object collection. It is going to have a pointer variable to an array of physics objects. So we'll say physics object star. We'll call it collection, I guess is fine. It has a constructor which takes a single integer, count, I suppose, and is the size of the dynamic array of physics object created when the collection is initialized. Okay, so in that case, all I have to do is say collection equals new physics object count. So my collection basically is just a class that has a pointer to an array of new physics objects. How many? This many. Modify the previous exercise to use physics object collection. Okay, so down here, I wrote this line, but I don't need this anymore. Instead, what I can do is I can ask the user for their number and then just make a physics object collection. So physics object collection, POC, I guess, equals physics object collection, and I'll pass it the number of physics objects that I want. So now I don't need this line anymore. And instead of PA, I can do let's see, it would be POC dot collection I to string. And otherwise, it should not actually have changed much. Let's make sure. Four. Yeah, and everything is fine. I haven't really changed too much, except that now I have a class involved. And the class, physics object collection, can do some stuff with my array of physics objects, if I wanted to. But for now, we're just starting out by replacing the code we had from before, by making a physics object collection, and now we can print it out, for example. Let's see what's next. Number 6. Add a method called addObject, which takes a physics object as a parameter. The function should create a new dynamic array, add all the old objects to it, plus the parameter physics object, then reassign the collection's pointer variable. Okay, so there's a few things that we got to do here. Why is this not saved? Weird. Okay, so exercise 6. I'm going to continue working down here. Add object, takes a physics object, create a new dynamic array, add everything to it, reassign the collection's pointer variable. So there's a few things we have to do. The first thing we have to do is you actually have to fix something, which is right now we don't know how big our collection is. We need a size. And so we're also going to initialize our size over here. Size is count, and then as we add objects, our collection will get bigger. So add object sounds like it shouldn't take any, shouldn't return anything. We'll add object, and it's going to take a physics object, PO, as a parameter. Now, I need to make a new collection. So I'm going to make a physics object pointer, new collection, equals new physics object, and it's going to be size plus 1. Now, for each physics object in my old collection, so up to the size, my new collection I is my old collection I. The new collection size, so that's going to be the last one, is going to be my physics object that I just got. Now, something to be mindful of is that I have to make sure that when I am putting my last physics object into this new collection, that I'm actually putting the last object in, which means I may have to pass this by reference. It doesn't really seem to say, but I know that whatever physics object I'm getting in here, I do need to be able to put that into my new collection. So I think what I'm going to do is I'm going to try it without by value first, and we'll see if this actually works. And if it doesn't work, then we can always go back and change it into reference later. But for now, we'll say the last one is going to be PO. And we'll see if this actually copies it how I want it to. Now, I have made a new collection. My old collection no longer needs to be here, so I will delete it. Delete my collection, and my collection will become my new collection. And that's it. So, was there anything else I was missing? I don't think so. So now let's make sure this works. Right now, I make a physics object collection, which means I have space for a bunch of physics objects. Right now I'm printing them all out. And now what we'll do is we will make a new one. Physics object PO equals physics object. So I got a new physics object. I'm declaring it just normally here. And we'll see what happens if I do POC.add object PO. And ideally, if this worked correctly, what I should be able to do is now go okay, well, actually I can simplify this as well. This used to be number of physics objects. Now I should just be able to do POC.size, which means I should be able to do the same thing over here. So this should print out my collection. I ask the user for how many physics objects are there. I make a collection to fit them all in and print them out. I add one more, and then try printing them out again. And we'll see if this works. Give me 3 and then add another one. So what has happened here? I got 0, 1, and 2, and 0, 1, and 2. So POC.addObject did not increase the size, which it should have. So let's fix that. Size plus plus. Okay, so the first time around, we should actually, let's put some space in so you can read this a little bit better. Sorry about that. Just add a bunch of stars. Always a reasonable way to split things up a little bit when you're trying to read what's going on. Okay, so first time around, I have 4 objects. I asked for 4 and it gave me 4. Masses of 62, 21, 10, and 91. Then I add an object. So I still have my 62, 21, 10, and 91, but now I also have a 64. A new one has been added successfully, which is a good sign because the physics object that I passed, I declared over here, and when I added it, add object is a pass by value method. I pass a copy of PO over here, and I make my physics object, my new collection, I should say, of physics objects. I transfer everything over, which means I'm just making copies of all my physics objects in the new one. I delete my old collection, update the size of my new one, and add in the new physics object, and then move the pointer so that I actually am pointing at my new collection with everything there. Down below, I think I can even get rid of this physics object and it probably wouldn't really make a difference. But the significant thing is that after doing my add object, I now have that object added to my, my collection. In fact, I can actually maybe try adding it a few times and we'll see what happens. Let's say I just want 2. So you'll see that I added object 3 times. So the first time I just have 2, 13 and 88. And then the second time, and then after adding, I add the 61 and 61 and 61, all 3 of the same objects. So it's actually making the copies and putting all those copies in the collection, which in this case is actually what I want. So it seems like it's working a-okay. All right, we're almost there. We're at 7 out of 8 is coming up next. Let's see what we have to do. Modify the add object method to take a physics object pointer as a parameter instead of a physics object. Ensure the old dynamic array is deleted. Okay, so I was working a little bit ahead to make sure that old dynamic array was deleted, but we're going to do it again anyway. So right now, our physics object, our add object is working with a pass by value, but we're going to make it use a pointer instead. Not too problematic. So it takes a pointer. Okay. So here's a pointer. The only reference to PO here, I believe, is right here. So instead of adding this, what we're going to do is we're going to dereference my physics object to grab the thing that's there. And I believe that's actually it. I think probably the maybe it's the case that if you forgot to delete last time, which I guess I thought ahead to make sure that I did. But in this case, oh, and let's make sure we call it correctly. When I want to add my physics object, I need to pass it the address of my physics object here. But the nice thing about this is now what it means I can do is I can actually dynamically make these physics objects. In fact, so in addition to passing this one by address, I could do something like the following. Physics object star PO2 equals new physics object. And I can pass PO2 as well. So let's see. So now I'm adding 2 different physics objects. One of them I'm creating statically, I'm creating it in the stack, and I'm passing a reference to it. The other one I'm making dynamically, and I'm passing the pointer to that dynamically created physics object. But I believe these both should still add the same way, essentially. In my actual code here, my add object, I'm taking a pointer now, which means that when I add the last element of my new collection, it should dereference that pointer to grab the object I want to put in. And always make sure you delete so that you don't cause any memory leaks. Oh, this is exercise 6, but it should be exercise 7. So let us go and I will make sure that we duplicate this properly. Oops, sorry. Okay, recovered. Yes, pointers, and one passed by the address of my static physics object, and one I'm passing a pointer to a dynamic one. But it should work in any case. Let's see. Looks like it compiled. Let's say I just want 1 to start. So my first one is 85, and that one sticks around, and then I add 2 completely different ones. This one was made statically, this one was made dynamically, but they still work a-okay either way. And now I can do it in either direction, as opposed to being forced to work with a pass-by value method. All right, one more, and then we're done. Okay. 8. Add a method to your physics object collection called deleteObject, which given a pointer to a physics object, removes that object from the array, then move all the other remaining objects into a new dynamic array and delete the old one. Okay, let's try it out. Properly duplicate my file this time. To exercise 8, the last one. So it takes a pointer to a physics object, removes that object specifically from the array, then move all the other remaining objects into a new dynamic array and delete the old one. Okay, so it's called deleteObject. It looks like it doesn't return anything, so it should be void. So void deleteObject, and it takes a pointer to a physics object. Okay. Now, what I need to do is see if the, I need to find the physics object in my array. So what I'm actually going to do is I'm just going to immediately start moving everything into the new dynamic array and deleting the old one. Although first thing I probably should do is double check that the object is actually in the array. So this is how I'll start. So for I0, I less than size, I plus plus. Well, while we're searching, we may as well keep track of where it is. So index to delete -1. So we'll say -1 means we didn't find it. But if we do find it, so if collection I is what's at our pointer, then index to delete equals I and break. And so what we're trying to do is we're going to go through our collection. We're going to see if we can find the one that we're pointing at. And if we do, we now mark that as the one we're not going to use. If index to delete is -1, this means we didn't find it. And we'll say not found. And that'll be it. Otherwise, we will go through int I equals 0, I less than size, I plus plus. And we need to transfer everything over into a new collection. So we're going to make a new collection the same way we made one with the add object, except this time the size is going to be 1 smaller. We're also going to need an integer j, which will start as 0. And the purpose of j is that it's going to be the index we use to go through the new collection while we use I to go through the old collection. So if I is not equal to the index to delete, then new collection j is old collection I. And j goes up. Otherwise, if we have found the one to delete, then actually we don't want j to go up. We want j to stay put, and I is going to go up because that's just naturally what it does anyway. Just like before, we'll do the exact same thing where we modify the size and we delete the old collection and then set up the new collection. So that goes here, and size is going down this time. So in short, our delete object should take a pointer to the thing we're trying to delete, find that index wherever it is. If we didn't find it, then we're not deleting anything. Otherwise, we make a new collection that has 1 fewer element. We copy over everything except for the one that we're deleting into the new collection. We modify the size because it's smaller now. We delete the old collection, and then we make our collection be the new one. And that should be it. So if this works, what we can do is, so we've added 2 objects here. We can print them out. Now we'll try deleting them. So poc.deleteObject takes a pointer to a physics object. So let's give it the address of PO. So it should delete this physics object here. and then we will try printing it out again. Let's see what happens. What did I mess up? Had some trouble converting. Collection I is star PO. What is collection I? Which line are we on here? Sorry. 88. Line 88. Oh, wrong file. This one. 88. Collection I equals star PO. And collection is my array of physics objects. What am I comparing right now? Physics object to bool. That's very strange. Oh, I'm missing a I'm missing an equal sign. That would do it. Ooh, that's a lot of errors. Okay, one moment. What is this? So now I'm comparing physics object and well, yeah, they're two physics objects. There is no match for the comparison of two physics objects. So this is unfortunately something that we're not going to be able to solve this week if I write the code this way. Next week we will learn exactly how we can equate two physics objects, but right now we can't. So you're a bit of a pickle, which is right now I don't really know how to... the only way that I can actually double check that these two are equal is to actually write a function to do that. So we will. We will call it bool same physics object, taking physics object PO1 and physics object PO2. This is going to return PO1.velx is PO2.vlx and y and z and also the mass. So if their x's are the same and the y's are the same and the z's are the same, y is y, z is z, and the mass, and the mass. And so instead of equals, I need to do same physics object collection I, comma, PO. Did I misspell something in here? I think I didn't copy this line correctly. I might need to put in some. Oops, I have an extra and at the end. Was that it? No. Same physics object was not declared in the scope. I put it somewhere that I shouldn't. There's another case I think I may need to declare this function before I run it. So let's declare it up above. Okay, try that again. It's not called VEL mass, it's just called mass. So let's correct that too. Over, where were we? Here we go. It's just the mass, not the velocity mass, because that doesn't mean anything. We compare all the velocities, y's, z's, x's, and the mass. Okay. Hooray. Now let's go. Give me 1. So I gave it 1, and it made this mass. Oh, let me put those asterisks in to help me separate my operations, so I can actually see what's happening here more clearly. Oops. Compile and run. Give me 1. Okay, so now I have this 180 is the first one that's made. I add 2. They're 12 and 16, and then 12 should be deleted because that's the one I added first, and it looks like it's exactly what happens. The 12 is gone, but 80 and 16 are still there. My size is 2, and everything seems great. So I think that wraps it up. Unfortunately, we did see one little issue we ran into, which had to do with the comparison of two physics objects to tell if they're the same. I had to write a function to do it. not quite nice. It's a lot better to be able to just say collection I double equals star PO. But the computer doesn't know what that means. What does it mean for two physics objects to be the same? One option I could have done, which I didn't, is if I wanted to, instead of making this a collection of physics objects, I make it a collection of physics objects pointers. Then I can just say, do the two pointers point to the same thing? And they're just addresses in memory. If they both point to the same spot, it's just a direct comparison. However, if I have two separate objects, how do I know if those two are identical? That's something where I would have liked to be able to use the double equal sign. And actually, next set of exercises, we will learn exactly how to do something like that. And I will see you then. Goodbye.